Hello, everyone, and welcome to today's SANS webcast, Raspberry Pi Sensors for Home Networks, sponsored by Corelight. My name is Carol, author of SANS, and I will be moderating today's webcast. Today's featured speakers are Gary Fisk, Security Engineer at Corelight, Richard Baitlick, Strategist and Author in Residence at Corelight, Jeff Stark, Principal Security Engineer at Megaplan IT, and Jesse LeGroux, Information Security Architect at Madison College. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Thanks, and thanks everyone for joining today. My name is Gary Fisk. I'm a security engineer at Corelight. We've got a great lineup today queued up. I'm going to try to get in and out of this relatively quickly because the heart of the order is the folks who are actually or involved in the program and getting useful information out of it. So I want to get to them as quickly as we can. But we've also got Richard Baitlick, one of the early advocates of network security management as a formal practice. And then we've got Jeff Stark, Jesse LeGroux, who have been working with the Corelight at Home program for a while now, and I wanted to share some results with you. Oops. Going backwards. All right, so to start with, Corelight is best known for development and advocacy of the Zeek network metadata framework or application that formerly known as BRO. And technically speaking, Zeek is a Turing-complete network event management application, or a Turing-complete network event development language. But the vast majority of folks who are using it for network metadata collection and analysis. The things that make Zeek logs different, though, is the ability to interconnect connection logs with DNS logs, with HTTP logs, to very quickly pivot across multiple different realms and fields of analysis, and making that sort of interconnectivity easy to manage. Another piece to this is each of those logs are built around someone looking at some sort of a log that previously existed and saying, this would be much easier if we had a few more pieces of information, or this would be easier if we could consolidate log A and log B. So here's an example of a DNS log where an operational DNS log would include a relatively short list of pieces of information, because managing DNS server, they're designed to manage the operational output of a DNS server, not security. In the case of a security analyst, you want, for instance, you want to be able to get the query and the response in the same place. From a DNS administration perspective, those are separate processes. So since security needs to see both of those, we've put them in the same same log record. So there's a lot of places where we've just tried to streamline the process to remove the friction across the actual usage of these logs. So Corelight traditionally has been all about Zeek and network metadata. We have recently included Suricata as a signature-based engine and integrated that into the Zeek logging framework. Functionally, this is the same Suricata you've come to know and love if you've been in this field, but it just makes the pivot from the flashing red light of a Suricata alert that says, hey, this bad thing potentially happened, into Zeek logs where you can say what happened 5 minutes before, what happened 5 minutes after, what's the context of that alert. It makes that process much, much easier. And again, all of those are going to be integrated across the stack. So in traditional deployments of, sort of enterprise deployments of Corelight, the way that this would be handled, and traditionally, this was done in a north-south environment, and that's sort of the diagram we see here, where you have a tap coming off of ingress and egress, and that can be a packet broker or a virtual tap or whatever. That traffic would then get fed into a monitoring interface of a Corelight appliance somewhere, whether it's physical, a virtual, cloud, whatever, and we would then integrate, take that metadata and ship that off to one or more of the data lakes in the top right for analysis and evaluation. With the introduction of Suricata, we've also added alerts into that, and we have the ability to extract files in a very granular way to be able to either be archived or sent off to file analysis tools and that sort of thing. So this is where we have traditionally been. And the origin story for Corelight at Home was, it actually began with the COVID-19 pandemic, where all of a sudden everybody went home and they left their offices. So we had a bunch of people who were interested in looking at Corelight logs and trying to get more information out of them, but suddenly lost access to their labs, and they lost access to all of the usual tools that they were dealing with. So we scrambled around and put together the idea for Corelight at Home, where we have the software sensor, which is, rather than being a physical appliance or an AMI in the case of Amazon Web Services, it's now essentially just a Linux app, and it can run on just about anything that runs Linuxy sorts of operating systems. And the Raspberry Pi was getting a lot of buzz these days, so we tried to we put together a program to make this easy to use at home. We've got, so essentially you take that same architecture where you tap your data, feed it off to a Corelight device, and send that off to a log store somewhere. We've got the link here. It'll also be included in a lot of the notifications around this webcast. We're wide open, so please forward this around. We'd love to have more people in the program, and we'd also love for you to share what you are seeing. One of the things that we have tried to do to encourage that is we have this wonderful contest called "What the Heck Is That?" where if people share the things that they have found, because invariably when you first turn this thing on, you end up looking at a bunch of the logs and say, "What the heck is that?" To share what they're seeing on their network, and we have a couple of winners whose names will be familiar if you paid attention in the early parts of these slides. We have Jeff Stark from Megaplan IT, and Jesse LaGrue from Madison College, and they are going to be speakers coming up here. But they have won a 3D printer, and this contest is ongoing. We have additional printers that we are planning to give away. So if you are a member of Corelight at Home, share your information. If you're not, sign up, and we would love to provide you the next 3D printer. So with that, I'll turn it over to Richard Baitlick to talk a little bit about some of the mechanics and some of the more structural side of how we can actually make get the taps working on home networking.
Great, thank you, Gary, and thank you everyone for joining us today. I know time is the most precious gift we all have, so thank you for spending part of that with us. I'd like to just briefly talk about some of the architectural issues you'll have to keep in mind if you're considering not only joining the Corelight at Home program, but doing any type of network instrumentation for your home network. Could I have the next slide, please? This material is derived from a post that I did at the Corelight blog. So if you prefer to read this material or to have a reference, just go ahead and go out to the Corelight blog. I think it's just corelight.blog. And you can do the search on Soho monitoring or Baitlick or whatever, and you'll find the post. The core issue I want to talk about briefly today is the difference between what you would find in an enterprise environment and what you would find in the typical, let's say, developed world infrastructure of a residence of some type. Typically, when you are working with a commercial ISP who is providing you home-based internet access, they are going to give you a all-in-one device that provides you with a link to their customer premise equipment, whether that's another box on the outside of your house or some other device farther down the line if you live in an apartment building or something to that effect. But this all-in-one device is going to provide two functions. It's going to give you Wi-Fi access, and if you're so inclined to use it, you will also get some wired access, usually off of a 4-port switch that's built in. Now, the question you have here is, where are you going to get your traffic to feed Corelight at Home? Because Corelight at Home is a little device that is running a custom version of the Corelight software. and it has a listening interface, and there needs to be a way to get traffic to that listening interface. So here we have, this small diagram showing this situation, and the way you might do it in enterprise would be to get a packet broker or to get a network tap or potentially a managed switch, and you would put it in one of these locations, either A, B, C, or D. You will do something similar, I recommend, at home, except you'll probably want to use some type of cheap managed switch. You can get these sorts of devices. Something like the Netgear GS105E is one that I've used in the past. Typically, they're less than $30 US, and you just need to make sure that it indeed supports a span port that can be managed by either command line or a web interface. Now, the question is, once you have this device, where do you put it? You cannot put it in location A. There's no way to get between the ISP's customer premise equipment and their other infrastructure. You could potentially put it at location B, and this is where a lot of people do deploy these systems. Now, the problem you're going to encounter if you deploy at location B is that the public interface on that ISP router slash wireless access point is going to be either a single public IP address that's been assigned to you by your ISP, or it could even be potentially a shared IP address that is provided by your ISP. And all of the devices that you have behind that NAT, whether they're wired or wireless, they're going to show up in your Corelight at home device as a single public IP address. This is fine if you're just playing around and you want to see like, hey, what's an easy way to see some traffic, and you're willing to sort of accept the fact that you've lost visibility into the true source IPs of your TV, your laptop, your hacked Peloton, whatever the case may be. Not that you have a hacked Peloton, that's a bad joke. But you have to keep in mind that NAT is going to be the problem you have there. You're not going to be able to monitor at location C. Modern wireless networks do not permit you to somehow see all of the traffic. There are ways potentially to do that, but you're not going to see the type of traffic that's going to be useful to you for a monitoring situation, perhaps for some type of situation where you're trying to break a Wi-Fi key or whatever, but this is not going to help you as far as passive monitoring. Location D is an option, but that would only be really good if you only care about watching your wired devices. And maybe that is the case. Maybe you want to set this up in a lab somehow, and you say, okay, well, I'm just going to monitor these few wired devices. In fact, that's how I test my my own Corelight commercial sensor at home. I have it on a wired segment like that. But let's say that you do want to have a situation where you can see pretty much all of your devices behind the NAT. What would that look like? Could I have the next slide, please, Gary? If you want to introduce that sort of visibility to your home deployment, you're going to have to break up the all-in-one functions that are provided to you by that ISP device. In other words, you're going to have to not rely on it for essentially your wireless. You're going to have to introduce your own wireless device, and then you're going to want to monitor in a place where you can see not only your wired devices, but your wireless devices. So as an example, I have here location D would probably be the best location if you wanted to see all of your private RFC 1918 IP addresses. So you would see the activity that is introduced by a new wireless access point that you've introduced, any other wired systems that you have there. Essentially what you have to do, the thing you have to keep in mind is you have to break up the all-in-one nature of that the box that you got from Verizon or whomever. That doesn't mean you get rid of that box. You just essentially set up some new infrastructure behind it. And could I have the next slide, please, Gary? It is possible to simplify that diagram a little bit. So I did pull out one of the devices. So essentially locations C and D are the same in this because they're on the same segment. But my advice would be, if you truly want to see private RFC 1918 IP addresses, your 192.168s, your 172.16s, your 10. whatevers, then I recommend getting a second wireless access point, getting one of these cheap little switches, and introducing that in the diagram in the manner that you see in the diagram here. And that will solve your problem for getting access to all of your private IP addresses. And again, for more details, if you want to read it, just check out the Corelight blog. And that's all I have.
Awesome, thanks, Richard, and appreciate it, Gary. So my name's Jeff Stark. I'm a principal security engineer for Megaplan IT. Been working with different network traffic analysis tools for several years now. Got a lot of experience between Suricata and Zeek. Being built upon Bro, it's been around for ages now, so it's pretty well developed, and it's pretty awesome what the guys over at Corelight are doing. So I'm going to walk you guys through, kind of where the rubber meets the road of everything we've discussed so far, and we're going to look at some incoming connection attempts from Iran. So to start off, I just want to go over my home network diagram so that you can kind of, maybe better visualize how we're intercepting this traffic. My home network's gone over numerous revisions over the years. This is actually probably the simplest, most simplistic it's looked in several years. I don't have a bunch of extra VMs, ESX host. At one point I had like a PF Sense running virtualized that everything was passing through. So, to kind of give you an idea, starting at the top left, we have my modem. So coming in from the ISP, my DMARC. I have that passing through, like Richard was talking about, one of those managed switches, maybe cost me about $30 to get. Now I have that very strategically placed, as you can see, before the next switch that goes to everything else that I have at home. And the main reason for that is that I wanted to be able to see the ingress and egress traffic. What across my entire network, I don't really see, individual devices as they're forwarding out, as they're communicating with one another. But what I'm able to pick up from this point is I can see that public IP that I'm assigned from my ISP and what it's reaching out to, who it's communicating with, and who's communicating with me directly. This is kind of visibility that you can't typically get on a home network. For anybody who's worked obviously in enterprise, you'd be able to see like firewall logs, and fingers crossed you have a good enough firewall that's also licensed appropriately to where you can see that kind of information. But this is a whole another layer of granular visibility that you wouldn't normally be able to have at home. And I think it's especially important right now as more and more people are working from home to be able to roll this out. So essentially that's where I have the little green magnifying glass pointing over to the, that's actually a Raspberry Pi case. It's the Argon one, and that's what I have Corelight running on. So it's picking up all that traffic in between my modem and that second managed switch. Following that down, I have a couple other Raspberry Pis deployed. So one, I actually have a full Elastic instance running. You'll see further down where I have some of the computers and laptops. Those all actually have the Elastic Security Agent on it. It's also providing metrics and forwarding back to that Raspberry Pi. It's a pretty cool project. And then I also have another Raspberry Pi that's running OpenVPN and Pi-hole. Pi-hole is essentially, think of it as like an internal, like at-home DNS server. All my devices go to it to get the DNS answer. It will cache certain things and speed it up. But the real value in Pi-hole is that it's able to, it has its own block lists. And so imagine, being able to block ads without an ad blocker. Instead, anytime your computer makes a DNS request out to that ad, it actually just gets blocked at the DNS level. And then you don't ever get those ad results delivered back to your browser. There's a lot of other really cool stuff that Pi-hole is able to do. Obviously, OpenVPN makes it to where, if I'm ever not home, I can always securely connect back. So really, just amazing stuff you can do with a couple of Raspberry Pis. I also have, the whole Philips Hue network cloud backup. I do have the wireless setup. And then, the myriad of devices, as right now I've got kids going to school from home, got my own setup. We've got all the IoT devices, everything else that the kids are playing on every day. And to kind of highlight what Richard was talking about, if I wanted to get visibility out of any one of these other segments, I could pretty easily do that. If I pivoted and moved the Corelight from essentially the tap that it's at right now, I could move that managed switch that it's connected to any other segment in here. Obviously, I can't get between direct wireless devices, but I could then start picking up on traffic from there. And actually, if I just moved down and essentially was mirroring traffic off of that second managed switch, I would be able to see lateral traffic. So if I have one system trying to talk to another, I'd be able to pick up on that kind of like lateral movement instead of the ingress egress, which would be more comparable to being able to detect things like C2 or, like we're going to discuss, inbound connection attempts. So getting into what is Corelight providing. So I have the Corelight at home sensor deployed and monitoring for that ingress egress traffic. Out of the box, they really have a great set up in partnership with Humio, which was just recently acquired by CrowdStrike. And I think I've seen that there's some cool integrations coming down the pipeline related to that. So I set everything up forwarding to Humio. Humio's actually got a whole free tier, which is really cool. It wouldn't work. I don't think it's the kind of ingestion you'd be expecting for like a small medium business. But for at-home use, it's excellent. Means that I didn't really have to spin up or configure anything. And there's a number of dashboards that Corelight provides. So what we're looking at here is actually the executive dashboard. And right in the center, what we're trying to hone in on is that there's a listing of top source countries with inbound connections. So US, is definitely the highest on that list. Inbound connections are going to be triggered by typically one of two things. Either I've initiated or one of my systems has initiated connection out, and maybe we're seeing responses coming back, or it's going to be standalone unsolicited inbound connection attempts. So pivoting down onto that, we switch over from a dashboard to more the search functionality. And then in here, we're able to build out what our search query should look like. Now, even on a home network, there is just a ton of data getting forwarded in. So we need to do a little bit of data validation before we are able to start asking questions and pivoting. So it's a little small, but you can see, I'm stating that I want to look at specifically the connection logs. I want to see where the IP location, or essentially I designate the IP location as the origin country field. And then I initially put that I wanted just all results where there is an ID origin country. Obviously, there's a lot of different types of logs. There's a lot of different, variations between what the different logs look like. And not every log includes origin country metadata. So that was, just initially to kind of flush out anything that isn't already including the origin country, specifically because that's what we're trying to pivot off of. There's plenty of, very valuable data in that. There's a lot of different things you could pivot down on. But for this use case, we just wanted the logs that had some sort of ID country or origin country metadata associated. And then from there, I wanted to filter out anything tied back to the United States. There's a lot of legitimate responses you might see from other countries. It's not uncommon. Microsoft and Azure both actually leverage a lot of international IPs. It's where we get a lot of false positives. We're investigating into that. But so, here we're just looking for a list of inbound connection attempts and the full list of countries. And then this is just looking over the last day. And we can already see in that bottom red box, Iran is one of the most active. And then we've got like a long list. So if I, really wanted to spend, greater part of a day, I could look through, analyze each one of these. From a business perspective, that's definitely what you want to be doing. But so, we're going to go ahead and pivot down on just the Iran connection. So here, you kind of have two options. You can see next to any given value, there's an equal signs where it's crossed out and then an equal signs in the little bubble. You can just click on that and it's going to automatically apply that filter for you. So in this case, I went ahead and said I only wanted to see the results where the origin country was Iran. And then from there, we're able to pivot down on all of the individual IP addresses that are making those connection attempts from Iran. And then here, again, we have account breakdown. A lot of different IPs. They're all within the same IP range, which is interesting. And we're going to pivot down on just the top value with the most occurrences. So in this case, there's 14 connection attempts in the last 24 hours. So from here, we can look at the raw data associated with any one of these events. So this is kind of a sampling. I have omitted some stuff just so that I didn't fill the entire screen. The top half gives you some of the more granular information related to what was seen from the network layer. The interesting thing that I want to pivot off of here is the connection state. So like I said, Zeek being built off Bro and having been around for so long, it actually has some amazing documentation. So every single one of these values can be pretty easily explained just by looking up that. For simplicity's sake, I only listed a couple of the connection state values just to highlight what you could potentially see. And some of the most common are going to be your S0, which means that a connection attempt was seen, but no reply was sent. S1 being that a connection was established, it has not been terminated. An SH is a SYN followed by a FIN. So there was no SYN accent. For anybody who's done any sort of penetration testing or maybe some light reconnaissance would know that a half open scan is a stealth scan. So we can actually pick up on that kind of inbound traffic. And then OTH is just saying that no SYN was seen. This is just midstream traffic. A lot of traffic gets categorized as that because there's already been an established connection, and then you're picking up on, the traffic as it's moving back and forth. And it's cool because then we can look at, the size of the traffic, how many bytes are being sent, and then kind of, draw some conclusions there. But for the sake of this example, we're going to focus in on the connection state being S0, so a connection attempt was seen, no reply. This is actually awesome to see because that means that we've picked up on it, we've identified Iran was trying to access our resources, but it was unsuccessful. As far as a workflow goes, I would want to go through, and actually what I did do is pivot down on every one of those sources and look for any instance where connection state is not S0. And pretty much if we went back 2 searches and ran that instead of pivoting down on Iran, then it could immediately give us the high level values of where was something actually successful in connecting in. Now, kind of continuing to run with this example still, we want to try to contextualize a little bit about what we're seeing. So, what I do in my day-to-day work, I'm a principal security engineer. I oversee a 24/7 security operations center. And a lot of what our team does is validates these kinds of things. So I want to kind of walk us through what does, the whole life cycle look like here? What would be our next steps? Now, just because we saw that the connection attempt was not successful doesn't mean this isn't still something that should concern us, especially considering, the volume. So some of the other countries, they made 1 or 2 attempts, maybe not, super high on our risk scale. But we have, one specific IP range that's just trying to hammer our home network. So one of the best open source resources I can recommend is the Open Threat Exchange, which is provided by Alien Vault. A lot of great information, a lot of companies and individuals both contributing these things called pulses. So people will have, just these honeypots out there that are collecting this information, and in an automated fashion, it's uploading these pulses to OTX. There's also a lot of very specific threat intel research that's been conducted, either by Alien Vault Labs or other organizations that contribute to the overall database behind OTX. So here I've pivoted down searching on just this IP. It does give us some basic information. So it's saying that it's located in Iran. It gives us the ASN. And then a full listing of any related pulses. The best thing that I like about this is that it doesn't just give you the pulse, but it also gives you the date when that pulse was published. All too often, there's a lot of IP reputational data out there. There's a lot of security vendors and tools that just have their own, or it's kind of pre-baked into the tool. But the problem is that a lot of times that information can be pretty stale. We prefer doing as close to real-time analysis, because if I wanted to go out and say I spun up a C2 server, or I was trying to conduct a phishing campaign, I can spin all of that up and then back down in like a day's time. And who knows how many people I would have potentially compromised in that amount of time. But most attacks, unless we're talking a pretty sophisticated APT, then we're talking maybe a week to less than a month that they're usually active. So it's just nice that we have a time frame to when this threat intel was shared. There's also network IDS signature hits, so this can give you an idea of what has that IP been seen doing to some of these other hosts. And I know it's a little small, but you can see that it's trying to do some SSH scanning. It's scanning a couple other Windows and BIOS ports, SMB ports, as well as doing some stealth scanning. There's associated URLs, which can be another helpful thing to pivot off of, but definitely great resource here when you're trying to contextualize information. Who is another awesome tool. Definitely recommend digging into the domain tools anytime that you come across a suspicious IP. Here we get somewhat different information than what we were seeing from OTX. So our IP location is now being identified as belonging to the United Kingdom. The ASN is a little bit different. And when we scroll down, we actually get some more identifying information. So we actually have an organizational name. And further down, actually that organizational name, worth noting, is registered in the United States, but further down, the individual associated with this record is in Russia, so the Russian Federation. So we're seeing a lot of indicators, a lot of very odd things that aren't necessarily meshing together. Every single one of these unique identifiers is actually something else that we can pivot off of and would be included as part of like a full investigation. But for our own purposes, we're just kind of doing some general information gathering at this point. Another great source, I'm sure everybody's well aware, VirusTotal. So you can search against individual IPs just to see, what might be potentially getting exfilled or associated with that. Here we can see that there was one engine that would have alerted on this IP. So it's not a lot, but it's also, a little telling that, this probably isn't necessarily an innocent IP. This would be a lot more interesting if it was related to potentially like C2 communication or command and control. You'll get a lot more information here. I wanted to kind of stick with the same IP instead of bouncing around. So we're not really seeing a lot here. It does show that there was a session.json file that was referred to in relation to this IP address. But if this was, say, a C2 server that was maybe unloading ransomware, you could potentially see those files. Obviously, we'd have a much higher score. So it definitely warrants having this incorporated into your investigation workflow. So overall, what are some of the lessons learned? A lot of people I don't think realize that their home networks are just under constant onslaught from all of these malicious actors out on the internet. There's a lot of legitimate internet scanners, but then there's a lot of bad guys out there too, trying to see where you potentially have a foothold. Shodan's another really great tool. If you do a lot of home labbing, you've got a lot of things deployed, maybe you've opened some inbound ports for various reasons. I definitely recommend taking a look at Shodan. I don't know that they're still doing it. They did have a discount because they just hit like 3 million subscribers a couple weeks ago. But what it allows you to do is up to, I think for a personal account, up to like 16 IPs, it will just kind of, scan your IP and let you know. It'll alert you if anything appears to be open, which is really nice to have. But ultimately, you want to have some layer of network traffic inspection between business or at home, especially I think at home with everything going on as far as the COVID response. More and more people are working from home moving forward. And it's a total blind spot for most people, most organizations that, as much as there have been a lot of security controls put in place, especially on the endpoint level to try to protect those systems that are, outside of the corporate environment now. Still, really important to be able to see this kind of stuff, especially engineers. I know a lot of guys are already doing some level of home labbing. So I can't recommend doing a Corelight sensor enough. How could this visibility assist you in general security operations? So the example that I ran through was obviously an unsuccessful connection attempt. But that's still really important for us to track on because it gives us an idea of the overall risk that's being applied against our home network. It's good to track on this kind of stuff, and potentially there might be something additional we can take out of that. Again, this was a pretty straightforward example, but if someone's pivoting and maybe they're attacking your a lot of vulnerabilities come up on a continual basis, and it could be that your home router is actually vulnerable, but you just can't see that. That kind of stuff would be evident from the network traffic visibility, and then you'd be able to take action on that and say replace whatever vendor or version of your home router. Additionally, it can help us identify things like covert channels, data exfiltration, C2 communication, and lateral movement. And like I said at the beginning, it really depends on where you position this as far as what you're going to be able to detect. So anywhere closer to the devices, anything across like the core switches maybe you use in your house, that's going to be able to detect what's being sent in between hosts. And then more where I'm positioned in between the ISP and my initial router is going to be able to pick up on any ingress, egress, things that are beaconing out to the internet, or maybe things that are being downloaded or intrusion attempts. So it's just worth considering when you're rolling everything out. And then personally, as far as what I'm going to be doing next, so as I touched on, I do have Elastic deployed. I know Corelight already has some support and documentation around their ECS format, so there is 100% a way to get that incorporated into Elastic. I've been using Humio so far. I like it, but I do know that just with Elastic, there's going to be a lot more dashboards. I have a lot more experience with Elastic as well. So I'm definitely excited to integrate those two systems and just keep detecting and pivoting down and finding more interesting stuff on my home network. And with that, I'm all wrapped up. I'm going to go ahead and turn it over to Jesse.
Great, thank you, Jeff. And I actually started in a very similar place as Jeff did in terms of where my sensor was actually located within my network. I don't have any diagrams of that to show today, but originally I did start having my sensor in between my cable modem and my router. I actually kind of move things around a little bit and actually have it behind just to get a little bit of better understanding and visibility into the internal network. If I did have unusual traffic that I did see, I wanted to know, well, what was doing it, and kind of dive deeper into that. So many different iterations and a lot of different ways to explore how to set this up. But either way, there's a large amount of information to gather from that. And this might look familiar to many. I'm using Splunk and AWS. I actually did use an Elk stack in addition to Humio. I tried a variety of options. Many of them work, and it always depends on kind of what you're using at the time and where you want to invest that time. So there's a lot of different ways to do this, which is really excellent. And right away, one of the items that I wanted to understand was, what does my overall network look like? You know, how many devices are on it? Is that number normal? You can kind of see from the dashboard about 18 devices. That might rise and fall day to day, hour by hour, but is that actually normal? You know, I was in a place where I was working from home. Many other people were working from home, and also having children doing school from home. So there's many more devices in one place at one time. And it's hard to understand exactly what's going on in different areas. Another item that even just this high-level dashboard gave me right away was understanding, you know, what is the volume of traffic and where is it going to and where is it coming from? And a majority of that in this case is actually DNS. Mine's, it's not quite to the extent that you see there. This is a little bit offset because internally I also have a DNS server, so anything not cached would go out and as well from that location. So in many cases, it might be duplicated. I am also using a Pi-hole as Jeff is as well for privacy and a few other items, and I also have those logs ingested here. So it's great to have more information to enrich that log data, but just with the Corelight data, you get a lot of great information and kind of understand where things are going. If you haven't looked at this kind of information before, you might be surprised at the volume of data that's coming in or out, the number of connection attempts specifically for DNS, for example. We might take DNS for granted on a day-to-day basis. We go to google.com and just anticipate it's going to work, without realizing that, well, that has to be translated to an IP address so that communication can take place. DNS is really a large underpinning to how we use the internet on a day-to-day basis. So this gives a variety of ways to start asking questions. What are these IP addresses? What are these destinations? And why are they there? I did do a lot of investigation into that, but I'm going to go a slightly different route. You might notice on the very top, I do have IDS or intrusion detection events. You might also notice those are very, very high. We'll get to that a little bit later in the presentation. And when you take a look at your traffic, you tend to find things. One of the interesting things one of the things I was curious about was, what are some of the outliers in my network? What are the most queried DNS? What are the least queried? What devices are communicating more or less on the internet? And this example is actually from an iOS device we have. We see a lot of DNS queries for this HomeKit. This is actually for a variety of Internet of Things or home automation devices for Apple HomeKit. We actually don't have any of these devices, well, to our knowledge. So far, the evidence shows that's the case, but it doesn't mean that some of our devices that we otherwise use on a day-to-day basis aren't searching for them all the time. And so we do see this is actually multicast traffic, both in IPv6 and IPv4 for HomeKit.local. So it's interesting to see where this communication is coming from, especially if you don't anticipate it. We actually don't have a lot of home automation items on our network at the moment. And this was just one of those, why is it here? And it's just a discovery mechanism that's used by the application. And there are a variety of ways to disable this, but still a curiosity. So one of the things that I actually wanted to dive into right away, I took a look at a variety of logs for the first month, trying to understand what are these IP addresses, what are these hosts, where am I downloading or uploading information to or from. But I actually got really interested in Suricata and the intrusion detection system, and what are some of these alerts that my network is generating? Are these anticipated or not? And you can kind of see even just from the graphs, I'm getting a variety of alerts. These are currently unfiltered. And I have to ask myself, is this anticipated, or is this something that is malicious or otherwise should not be happening? And we'll kind of dive into this, but I found this a really useful aspect to using the sensor is not just getting a better understanding of what's communicating on the on my internal network, but what part of that from open source intelligence might be malicious. And a lot of this is just like any tool. Part of it is understanding what is normal for you, what's normal for your network, and using that information to understand, what is the threat in your context. My home network is going to be very different from a corporate network, from an education network, from a research network. Each location is going to have different requirements, different policies, and those are very important to keep in mind. So I took a look. This is a snapshot of about 30 days of data to find out what am I getting alerted for these intrusion detection system. And at the very top, I do see observe DNS query to .cloud top level domain. In a corporate environment, this may or may not be a red flag. In a home environment, it's definitely not. A variety of services are using .cloud or other top level domains. It's not just .gov, .edu, .com. You will see even lower down, you'll see .biz, .life. Some of these are common, some of these are not. So for my home context, when diving into this, I could see a variety of resources that were being used that were actually valid resources, at least from a home context, and weren't something to be suspicious about. But I highly recommend, if looking at this information, it's a great educational experience to go through every single one of these alerts and better understand, why is this happening on my network? Why is this happening with certain devices? To better understand what that normal looks like. As we do look at any kind of security, knowing and understanding what normal is one of the fundamental first steps. If you don't know what normal looks like, you can't report on deviations to that normal. And normal does change over time, but it helps us better understand what that threat landscape looks like. So I wanted to center in on a few different items that right away I did see as interesting. At the very top, I do have metadata retrieval. In this case is, we have plug and play USB devices we plug into our computers all day. And when you plug something in, it might actually have to reach out to get information about drivers, or potentially just report metadata for other uses. And in this case, this was to Microsoft, either for drivers or other metadata information. And you can also do packet captures to gather it. But it is very interesting to see what data is reported based on just a USB drive that you plug in, a keyboard, a mouse. Many of these calls do happen on a regular basis, and it doesn't mean it's necessarily malicious, but potentially it could be a privacy concern depending on your interest there. And in the middle, I also found this interesting of having a threat for COVID-19 domains. There are a lot of phishing campaigns out there, so emails where they're trying to get you to click or respond to something where you shouldn't. So there was an alert for anything with COVID in the domain name. It was false positive in my case, but it was an interesting item nonetheless. but I'll dive into a few of the other interesting points. So at this point, I had been using the sensor. I had set up a lot of the alerting in place, and I've also filtered a lot of the normal alerts that I see on my network. So a dot cloud I might anticipate as being normal, I'm going to filter that out from daily alerts. So I'd actually get an email every hour for anything that seems suspicious. And so, one night I'm updating my phone, I restart it, and I take a look and I get an alert top of the hour, and I look, oh, there's a .onion domain apparently trying to be resolved on my phone. And it turns out that it happened just after I updated it. And so in the back of my mind, I'm considering, supply chain compromise or other malware that might be on my device. Granted, at this point, I hadn't had everything in for a very long period of time to understand, is this simply a deviation from this one update, or was it something that I might have seen a month ago if I'd have been looking for a longer period of time? That I can't state for certain, but it was an interesting coincidence to see this traffic happening right after I performed this update. When taking a look at the logs, I did find out that there was a .onion domain query. I was able to capture, the UID from the signature that fired and pivot over to the DNS logs to get additional information. So I can see this google.com.onion. I also see the R code name, which is NX domains or non-existent. So it really didn't resolve. There's nothing to communicate with. However, the query was attempted. So there was no connection to be concerned about, no data transfer, but it still did beg the question, why is it trying to access this google.com.onion domain, and why is it there? It does appear that it's not malicious, but it still begs the question. And whenever we have a question and are not quite sure where to go, many times we go to Google, which is exactly what I did. And I did find out that many others had answered this in the past, and this is actually part of the wireless intrusion prevention system that comes with a variety of Samsung devices. And you can see that the resolution is there really to help the software make better comparisons to understand whether or not certain things should resolve. And others noted that it was extremely suspicious. They had the same questions that I did, but it also was something that for our devices was not that abnormal. So very interesting to see that happened. I do actually notice now, I still get those alerts. I've gotten, I think, 3 updates since then. One of these days I'm waiting for that alert to disappear, and I'm capturing information about the version of my phone. I do notice when I do disconnect and reconnect from my access points where it does change and move from one access point to another, generally that DNS query will pop up on those disconnection or reconnection events. So at least I can pinpoint a time as to when, and it is from the system and common with Samsung phones. But without actually having the system in place, I wouldn't have seen it. It would not have been a question that I'd asked. And if I bring my phone to any other location, including to a corporate environment, it might be something commonly seen within a corporate environment that, without having this data, you wouldn't see. So it was a very interesting piece of information, and probably something that's happening all over the place, especially since mobile devices and BYOD is becoming increasingly common, especially as there is more remote work and potentially more personal devices being used. And what good is being stuck at home for over a year without being able to do not just 1 but 2 Raspberry Pi projects? And so one of the items that I took a look at was DShield from the SANS Internet Storm Center. And so I set up another Raspberry Pi with this DShield product to contribute back some data in terms of threats in the wild, but also to better understand what am I going to see on this Corelight sensor now that I'm getting all this data? What is that going to look like, and how can I use that data? And right away, all the alerts that I had seen, maybe from my Suricata, maybe a high of 20 a day, they exploded, and I received significantly more alerts than I did in the past, which is anticipated. You never quite know how a system is working until you truly test it to understand whether those alerts are going to fire. And rather than the 20 alerts I might receive per day, now I'm getting upwards of 2,000 plus. And it's happening from a variety of locations throughout the world. And this is a great piece of just this Suricata data to understand what alerts are firing and what are some of those locations that might be a threat. And these IP addresses and other source data can be further enriched using data such as Shodan, such as various WHOIS databases to better understand what those sources are and potentially why they might be doing what they're doing. But a lot of these are flags based on IP address sources from many of these alert signatures. And another type of view to better even use geolocation to understand where those communications are coming from, what specific IP addresses and ports, what they're communicating to and from. So once again, it's great data to see if you do use the internet at all, which you're here today. So dangerous is a very dangerous place, and there's a lot of just automated scanning and attacks happening on a day-to-day basis. And it's interesting to see this data. You can see that port 22 all the way in the right-hand side, very commonly attacked for SSH. And over a 7-day period, you can kind of see spikes with different source locations, but also different attacks for different ports and different destinations. And by far, SSH is the most attacked. By unique source IPs, actually Telnet port 23 was a little bit more common, but overall in terms of volume, SSH is more common. But this is basically continual attacks from the outside all the time. And for this honeypot, it's also gathering other data. And since I didn't decide to enable the file extract option, which also allows for unencrypted data to be captured and stored. I actually did modify this as well to allow for shell scripts, that shell script MIME type, and then use a VirusTotal API to understand whether there are any results for this. In this case, the one on top, 35, which is pretty high, and then the link to understand whether this is malware or not. So you can kind of see that a lot of the attacks for the Pi and things they're trying to have the honeypot do is actually to extract and download malware or vectors for malware to be downloaded. And these can also be extracted, and you can actually see the commands in there. So this was an example of a couple, in this case, a bin file, an ELF file, and a shell script that was actually downloading additional data. So it gives, if for anyone interested in reverse engineering, it gives a great way to engage with that data and to understand these threats in the wild. And you might be surprised, most everything is unencrypted. We have a lock on our websites, but you might be surprised with what is not encrypted. You might know from even this information on the screen, what shows I may be watching or may have watched, but also even surprising that updates for a variety of applications also come unencrypted on the wire. And so you can get a lot of information about that and many other pieces of data from your network. So don't just look for the data, look to see what's encrypted and not. You'd be surprised what you find.
All right, thank you very much. Those were both fantastic presentations. Like I said, it gives you a pretty good idea of how we named the contest. What the heck is that? Because virtually everybody finds something that they did not know about as they come across here. So I'm going to do a very, very quick walkthrough on some of the configuration process. We're getting a little short on time, so this is going to be pretty quick, but the configuration is pretty easy too. So when you fill out your evaluation, we will send you a link to a portal that will give you access to the documentation and license file. From there, basically, all you have to do at the command line is to grab the script to do the installation off of GitHub. We're called Raspberry Corelight, which is essentially just a relatively complex shell script to do the configuration of the product itself. So we've got this quick config utility that will run through all of the major pieces to it. The standard installations of Raspbian are 32-bit, so the first step on it is going to be to upgrade the kernel to 64-bit, but that is all handled by the script. You can then define what interface you want to listen on, which should be ETH0. Apply your license file and configure export. For Splunk, you indicate a URL, so you can either have this be a local Splunk instance or Splunk Cloud. We use HEC for both Splunk, or the HTTP event collector for both Splunk and Humio, which is configured thusly. As one of our presenters mentioned, I forget who, Humio was recently acquired by CrowdStrike, which raised them in visibility a bit. You can sign up for a 7-day a rolling 7-day trial for their cloud instance, which is how I've used it, and I think that Jeff did as well, and it's worked quite well for us. But you can. There is an approval process at Humio that has added a little bit of time to it, so this isn't an instantaneous thing, but it's relatively straightforward to set up. I mentioned before that we have the adaptive portal. That is also where you will get the public key for installing the software itself. So when you sign up for the adaptive portal, keep track of those credentials. You have to put them in when you are installing the software. And there are a variety of other tools that are available with the Raspberry Corelight utility. One thing that I would point out specifically is removing the IP from ETH0. The monitoring interface does not need to have an IP address on it, and as in my case, my monitoring interface is outside of my NAT gateway, so I wanted to have as little surface area there as I could, so you can remove the IP address and it will just pull in that traffic for you. And this is, like I said, it's just a shell script that edits the configuration file. If you would like to open up VI and geek away at editing the shell script itself, or the config file itself, that is very certainly supported as well. We are still doing the what the heck is that contest, so please, if you are working on this or intend to, do share with us what you do, what you find. We have a Slack channel that we use for support. You will be invited to that when you fill out the evaluation form as well. And you can use that either to share your experiences or to get in contact with us to do the same. We'll be sending out the slides, so you don't have to write all these things down, but here are your references for what we've built on here. I always want to call out the active countermeasures folks. They have been the sort of inspiration on this whole thing to start with. So I want to make sure that we give them a shout out, because we borrowed heavily from the work that they did, and they're good folks. If you're not watching their webcasts, you probably should be. But with that, we've got about 2 minutes left, and thought we'd throw out an opportunity for any questions that are out there.
All right, thanks for that great presentation. We do have quite a few questions ready for the Q&A, so I do want to let everyone know that I'll be sure to send the questions over to Corelight for a response, because it's unlikely we'll get to all of them. We'll start with one here. Don't most ISP modems routers have a default deny on the inbound and require explicit port forwarding to allow inbound to the inside interface? Was that the case in the demo? And if so, did Jeff have that opened up so he could see that traffic? Kind of a long one, so I'll post that in the chat window as well.
Hi, yeah, this is Jeff. So I actually have that positioned directly in between the modem and my router. So it's actually in front of that. Corelight doesn't require an IP, it just needs raw traffic that it can read. So what you're referring to in the question is, typically what would be configured on your router. And that's gonna, block anything inbound. I'm actually positioned right in front of that. And so it doesn't really apply based on where I've set it up.
All right, thanks. We'll squeeze one more in. Can you address the privacy concerns using these third-party tools or services to monitor home traffic?
Yeah, so the only third party, we actually originally were thinking about trying to extend this as a way to extend corporate security policies into home networks as people moved out during the COVID-19 pandemic, but ran into exactly that problem. That this is why we wanted to make sure that you had control over what went where and how. If you would like to keep everything on premise, you can install a local Splunk instance and nothing ever leaves the building. If you use Humio Cloud, that is going to be a third-party service. We do get telemetry from these devices, but it is only a matter of license validation, and, version deployed, that sort of thing. So we have been conscious of that. If you are concerned, this is obviously a much longer discussion than is probably appropriate for the end of a webcast, but we are more than happy to have those conversations to make sure that you are only sending out the things that you would like to send out.
All right, well, with that, we're out of time. Thank you so much, Gary, Jesse, Jeff, and Richard for your great presentation, and to Corelight for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.